Alright, we're on number 16 of the Unit 3 practice problem sets. And it says a radioactive substance has a half-life of 57.2 days. We want to find the material's daily decay rate and the continuous daily decay rate. So all I have is the half-life. And in these scenarios, when you're given nothing but the half-life or nothing but the doubling time, generally to get the model you're going to have to do regression. That's my preference. You could do the formula for 2 points, but I prefer to use regression. So at time 0, I'm going to have 1, and at time 57.2, I'll have a half. And then I'll do regression with that data set. So let's go to the calculator and do this. I need to clear my list too. Okay, here we go. 0, 57.2, and 1.5. Now I'll do regression. Exponential regression. That's my function. And I also have my factor. So now we can get to the questions. If I want the daily decay rate, here I have the factor. So I just need to get the rate from the factor. Now I always tend to get this in terms of the growth rate and then change it. So that's going to be what I do here. And this all comes from the relationship that b equals 1 plus r, therefore r equals b minus 1. That's growth. So I will say var's statistics equation. I'm calling up b is what I'm doing here. And then I subtract 1, multiply that by 100. And that's negative because it's the growth rate. So the actual decay rate is positive 1.204. Okay. Now if I want the continuous daily decay rate, what I'm going to do is find the continuous daily growth rate, RC, and I'm going to use this relationship, and then I'll change the sign of it. So once again, I need that b value. So ln of var's statistics equation b, multiply that by 100, and I'm looking now at the growth rate. That is the continuous growth rate. So RC is negative 1.212. And so decay rate is positive 1.212%. Positive 1.212%. All right, so that's number 16. And let's finish this up. Number 17, that's the last problem, I believe, so let's do it. This is one of the mixture problems about paint. A painter needs 10 gallons of a paint with the following composition: 17% red, 27% green, and 56% blue. She has access to large quantities of 3 paints A, B, and C with the compositions given in the following table. What quantities of paints A, B, and C must she mix to fulfill her need? So with any word problem, we have to start by looking at the question. And our question says what quantities of paints A, B, and C. So my variables are going to be A, B, and C. So A will be gallons of paint A, for example. B will be gallons of paint B, and C will be gallons of paint C. When I get to the calculator, I'll have to do this as X, Y, and Z, but for the moment, I'm going to leave it A, B, and C. Now, can I write a simple total amount equation? Yes, I can. I need 10 gallons, so I know that A plus B plus C is going to equal 10. That's the easiest equation to write. Now I can write pure color equations. So I can write a red equation, which will actually be red. So my red equation is going to be the red contributed from each of these. So the red contributed from paint A is 15%. So that's 0.15 of A is red. Now how much of B is red? Well, 60% of it is red, so that's 0.60 of B. How much of paint C is red? Well, just 5%, so that's 0.05 of C. And altogether that should make 17% of the 10 gallons. So that's going to be my red equation. Then I can do a green equation. So this is going to be how much green is contributed by each paint. So paint A contributes 75% green. So that's 0.75 times the total amount. Paint B is 5%. Paint C is 15%. And the final amount is 27% of the 10 gallons. And I could also write a blue equation, but I don't need to because this is 3 equations. So that's 3 equations. That's enough to solve for my 3 variables. So now let me write the matrix for this. The matrix is going to be, I guess I don't really need to bother doing X, Y's, and Z since I'm going to go straight to the matrix. But this would be 1, 1, 1, 0.15, 0.6, 0.05, 0.75, 0.05, 0.15. And then I'll need to take the inverse of that and multiply it by my coefficient matrix, which is 10.17 times 10 and 0.27 times 10. So I'll need to put those into the matrix, into my matrices. This matrix A is going to be a 3 by 3. This is 3 by 3. And this will be a 3 by 1, and then we'll have to invert and multiply. So let's go to the calculator and type all this stuff in. Go to Edit, choose A. Now make sure you put in 3 by 3. And my values are 1, 1, 1. So my first row is correct already, actually. Then 0.15, 0.6, 0.05. Row 3 is 0.75, 0.05, 0.15. That's matrix A. Now we need to edit matrix B, which is going to be a 3 by 1. And its values are 10. And then I like to do the multiplication just within the matrix. 0.17 times 10 and 0.27 times 10. And that's matrix B. And so now we're ready to do our final multiplication. Call it matrix A, take the inverse, and multiply it by matrix B. And there's our paint amounts, our gallons. So we need 2.29 gallons of paint A, 1.76 gallons of paint B, and 5.94 gallons of paint C. And that concludes the Unit 3 practice problem set.